Hello, Christian here from McDonald Educational Technologies. In this video, we're going to discuss how to secure your Windows Ldap servers using Let's Encrypt certificates. If you like this content and you want to see future content very similar to this, where I talk about things that I find interesting, make sure to hit that subscribe button and hit the bell icon to make sure that you don't miss any future videos. Back in August of 2019, Microsoft released a security advisory 190023, and I'll make sure to post all the links to the articles and any of the software that I use in the description. But this article is discussing Microsoft's recommendations for enabling Ldap channel binding and Ldap signing to increase the security for communications between Ldap clients and Active Directory domain controllers. When you install Active Directory domain services, by default, the configuration is not very secure. You get no TLS on top of Ldap, so it's just unencrypted, unsecured Ldap over port 389, and up until recently, channel binding was disabled. Now, channel binding, we're not going to go into that in too detail, but in essence, what it does is it takes the transport layer and the application layer. It creates a unique fingerprint that if anything is tampered with in that communication and the fingerprint changes, then the Ldap server will invalidate the connection and not actually serve the client. Ldap signing is what we're going to talk about today, because that's actually a requirement to do channel binding. We need to actually serve Ldap using a certificate, a valid certificate that the client trusts, in order to actually encrypt that traffic. So we're going to enable Ldap over using TLS with third-party certificates on our domain controllers. Now, there's several ways that you can go about enabling Ldap over TLS. One way is using third-party certificates that are trusted by routes that exist on your client and your server. The other way, which is a lot more work and has a lot more overhead, is to actually spin up Active Directory certificate services, actually spin up your own on-prem certification authority to actually issue those certificates. That is a terrible, over-engineered solution to this problem. Okay, Let's Encrypt certificates are free, and I'm going to show you in this video how to even automate their renewal on your domain controllers, so your domain controllers are always up to date with a valid certificate and are always compliant and issuing and serving Ldap over with TLS on top. So there's a couple of requirements that need to be considered before we go into this. First of all, your Active Directory domain name has to be a valid TLD or a valid subdomain of a valid TLD. And this is really important because third-party public certification authorities will not issue certificates for non-valid, non-routable domains. Okay, so we have to make sure that your domain name is a public, valid TLD. In my case, I always use a subdomain, but your environment might differ a little bit. But if you haven't been following Microsoft's recommendations and best practices for probably at least the last 2 decades, this is probably not going to impact you. But if your Active Directory domain is a .local or .corp or whatever, a non-valid, non-public TLD that you don't have publicly registered, you will not be able to get certificates from any public certification authority. And you'll have to consider other means that are beyond the scope of this video. So assuming that you have your Active Directory domain is publicly registered, or at least the TLD is publicly registered, we can proceed and move forward. Enabling Ldap over TLS is actually really simple. There's no switch to enable. There's nothing that you actually have to check. There's no registry keys that have to be modified. All you have to do is drop a valid certificate into the local computer personal store on your domain controllers and reboot them. When you reboot your domain controllers and the Ldap server reboots, it'll look in that store for a valid certificate, and if it can use that certificate, if it meets these requirements, it'll use that certificate and use that to bind to the Ldap server and actually begin to serve secure LDAP over port 636. And really the only requirement that I've found that the LDAP server looks for is this one right here. The Active Directory fully qualified domain name of the domain controller has to be listed either in the common name field or as an entry in the subject alternative name field. Beyond that, you can add domains and you can have multiple domains, and you're actually going to see, I'm going to show you what I do with my environments. But this is the only requirement. So if your LDAP server sees a certificate that has the FQDN of your domain controller listed in either the common name or the subject alternative name, then it'll bind that certificate and just begin to use it. There's no checkbox, there's no question, there's no registry key that has to be enabled, it just works. Okay, and Let's Encrypt certificates are valid for use in server authentication. Everything else is just fine. Let's Encrypt certificates are totally valid for this use case, and they work really, really well, and we're going to show you how to do that now. So the Let's Encrypt client that we're going to be using is the Windows Acme Simple client, or the WAX client. This is a Acme client written specifically for Windows. It's written in C#. It's actively maintained, and I'll link to this in the video description and also to the Patreon page for the maintainer. I would highly recommend that you donate. I actually am a patron of this project because it works really, really well, and in my opinion is the best Acme client for Windows. It supports the latest version of Acme v2, wildcard certificates, DNS validation, and it has built-in scripts for IIS and RDS certificates. It does a lot of stuff, and it's really, really well maintained. We're going to go ahead and download the latest version. As of this recording is version 2.1.11. When you scroll down to find the release files, you're going to see several options. First of all, make sure that you download the pluggable 64-bit version. Okay, if you download the 64-bit trimmed version, you're not going to have access to the DNS validation plugins. You need the pluggable version. The pluggable version is a little bit bigger. It's about twice as large in file size, but it has support for plugins. And because you probably don't want to expose your domain controllers to the public internet, we can't use HTTP validation. We have to use DNS validation. Now, as of this recording, win-acme client supports Azure DNS, Cloudflare, DigitalOcean, DreamHost, Lua DNS, and Amazon Route 53. So you'll need to make sure that your domain is hosted on one of these providers. And these providers provide a very robust API that have, in this case, plugins that use those APIs that win-acme can hook into to actually create and modify and delete records during the DNS validation process. So for me, I am a really big fan of Amazon Route 53. So I'm going to go ahead and download the Route 53 plugin and the pluggable version of the win-acme client. Now, this video is going to be using Route 53 as the DNS provider, but more or less the process is identical regardless of the provider that you use. And I'll talk about where that process deviates as we go through this tutorial. So once we download these zips, the plugin and the client, you're going to want to right-click on each one of those zips and choose Unblock and Apply. This is important because the code is not signed and we're downloading binaries and we don't want them to be erroneously flagged as malware, especially when we move them over to our domain controllers. Once you do this, you're going to want to take the DLLs that you extracted for the DNS validation plugin. In this case, I'm using Amazon Route 53, and we're going to copy those into the root of the win-acme client folder. And then this is what we actually need to copy over to our domain controllers. Now, I'm not going to go into how you might accomplish that. You could just, whack your domain controller, whack $, and copy the files that way. In this case, I use I use server core for all of my domain controllers. So you're going to have to find a way to get the files over there. On my domain controllers, I put the win-acme client under C/tools/win-acme. So right on the C drive under tools, and then win-acme, so I know exactly where this particular program lives on all of my domain controllers. We're going to go ahead and launch the win-acme client by typing in WACS, and you'll see that you have the correct version. If the version is release and then pluggable, that's really important that the version, in the software version, it says pluggable. Now, if you want to make sure that you actually loaded the DNS plugins, you can do WACS and then use the verbose switch, and you can actually see it loading the validation plugin. So you can see here on the second line, it found a plugin for Route 53 at this location, and it loaded it successfully. So I'm going to go ahead and quit that. We don't really necessarily need the verbose version to do this work here. All right, so we're going to go ahead and open up the WACS client, and we're going to choose M for create certificate with full options. Now we're going to go ahead and choose manual input because the win-acme client can't find any site bindings from IIS. So if you had IIS installed and serving, it would actually try to figure out the domains that you might want to protect from IIS, but because there's no IIS on this domain controller, you should not be running IIS on your domain controllers. We're going to actually have to manually input those domains. So we're going to choose 2 for manual input, and then we're going to type in the fully qualified domain of this domain controller. Now I'm going to be blurring this out, but I'll give you an example of what you might type in on the screen. And this is a comma-separated list of host names. So besides this, I'm also going to type in just the domain, just the Active Directory domain. And then I'm also going to use another domain called Ldap dot, and then my domain, my Active Directory domain. And this is something I use just for convenience. On all of my Ldap clients, I just know to type in Ldap dot my Active Directory domain. Again, I'll put an example on the screen, but that just helps visually for me to know that I'm doing Ldap. So I have 3 domains: the FQDN of the domain controller, which this is going to be specific to the domain controller. And then we have the FQDN of the Active Directory domain itself. And then we have this new Ldap dot, the fully qualified domain of the Active Directory domain. We're going to hit enter, and we're going to hit enter again. WACS is just recommending a friendly name. For this, I just choose the default, click enter. And now we're going to get a list of the ways that we can do the verification for the domain ownership. Now, if you do not have your DNS validation plugin installed successfully, your list is going to be shorter. We cannot use HTTP validation because we're not going to expose our domain controller to the public internet. We have to use DNS validation, which doesn't require opening up ports and doing fancy things with your firewall. It just sends, in this case, a REST request up to AWS to create the records in Route 53. And then once the records have been validated, the plugin will automatically clean them up, and everything is great. So we're going to choose 6 for Route 53. The next question here is going to be specific for Route 53. So if you're using Azure, DreamHost, DigitalOcean, Lua, etc., the questions here are going to be a little bit different, but you're going to need to follow the instructions for your DNS provider for generating an API key and a secret typically. In this case, we're using AWS, and it's asking for an IAM role for EC2. Route 53 does not use EC2 instances. There's no IAM roles for EC2 or for Route 53, so we're just going to leave that as blank. And now it's asking for an AWS access key, and it's going to ask for a secret key as well. So we need to actually go to Azure and create our keys. So the way that we're going to do this is we're going to follow some best practices, and actually create a user that is specifically for Acme, that is only scoped to have the permissions necessary to create and update records in Route 53. And the way that you'll do this is you'll first create a policy. So you'll go to IAM, Access Management Policies. You'll create a policy. In this case, the policy is called Acme Policy. And under permissions, we're going to give it permissions to Route 53. And these are the permissions that I have listed here. Now, you can actually scope this out to only allow changes from specific source IPs. And you can even scope it to specific resources. I didn't really feel that was necessary to scope this out to a specific resource in Route 53, but these are the actions that you need to allow your IAM user access to actually do what it needs to do with Route 53. So you need Route 53 get change, get hosted zone, list hosted zones, change resource record sets, list resource record sets, get hosted zone count, and list hosted zones by name. These are the, 7 actions that you need to enable. In my case, I just have resources as a wildcard, and the condition for conditional access is IP address, and then the source IP is my CIDR notated public IP addresses for my site. Again, this is going to be blurred out, obviously, for security reasons. Once you have this policy created, again, I'm going to post the redacted JSON policy in the link in the description below. I'll post it on Pastebin for you to copy and paste if you're using Route 53. That might be useful. The next thing we're going to do is create a group. In this case, the group, we're going to call it Acme Users, and then we're going to attach the Acme policy to this group. And then when we create an Acme user, we're going to attach the user to the group. So let's go ahead and go under Acme Users, and we can see that we are using the Acme Users group, and there's an attached policy to that group, and this scopes this user to only have access to the policies that are defined in the Acme policy. And in this case, that Acme policy can actually only be invoked from that IP address range that we defined in the source range. Now we're going to go ahead and create access keys. Obviously, for security reasons, I'm going to go ahead and delete all of these and create a new one for demonstration purposes, and then I'm going to obviously create new ones after I finish filming this video. So we're going to go ahead and create a new access key, and we're going to copy and paste the access key and the secret access key and somehow get those onto our domain controllers. Again, I'm not going to talk about how you might do that. You might create a text file with this key and move them over using, you might create a text file and move them over using SMB. Just whack into your domain controller, $, and do it that way. Okay, so once you have your access key ID and your secret access key on your domain controller, you can just copy and paste each one into their respective fields in Wax. And again, this key ID and secret access key, I'll destroy these after the video. And we're going to choose RSA key. And then we're going to choose the default location to store the certificate, which is the Windows Certificate Store. And we don't want to store it in any additional places in this case. We'll choose 5 for no additional store steps. And then in this case, once you have a certificate installed, the Ldap service continuously looks for certificates, and it should bind them automatically, so we don't need to do any additional steps to install the certificate besides placing it in the certificate store. So we'll just choose no for additional install steps. And once we choose that, it will begin to attempt to validate the domains using Route 53 DNS validation. So it's going to have to walk through every domain. It creates the text record for the Acme challenge with the value. It waits for the DNS changes to propagate, and then it will validate them one at a time. So I'll speed up through this part of the video as this can take a few seconds. Okay, and once you get through this, it will say adding certificate and then the friendly name to store my, which in this case is the computer personal store. It'll automatically create the scheduled task for renewing. It'll add the renewal and it'll schedule that renewal. And once that's done, you can quit the Wax client. So there are a few other settings that you might want to consider changing that might make your life easier. And depending upon how your DNS is configured locally, you might need to configure additional settings with Wax to encourage it to do preliminary validation against an external DNS server and not your on-prem DNS servers. Obviously, the preliminary validation step is going to fail if the Acme client is trying to validate the presence of these records against your on-prem DNS. Because remember, we sort of have a split-brain DNS situation here, where we have our on-prem Active Directory DNS, and we also have this DNS that lives out in Route 53. And the preliminary validation step needs to check the external DNS, not your on-prem DNS. So if you're having issues with the preliminary DNS validation failing, you might want to go in and check the settings for the Wax client. So we're going to go ahead and open up the settings.json file. And if you scroll down to validation, there are some things you might want to change. So I would recommend setting DNS servers to explicitly be external DNS servers. So in this case, I have 8.8.8.8, 1.1.1.1. So this would be Google DNS and 1.1.1.1, so Cloudflare DNS. And I have their primary and then their secondary set for that as well. So if you find that your preliminary pre-validation is failing, make sure to enable this as you see here, and this will force Wax to use these DNS servers and not the DNS servers that are defined on the machine. Obviously, if the Wax client is using the local DNS infrastructure in your Active Directory environment, it's never going to see those text records to do the validation. So if you're seeing that, go ahead and add that, and that should fix that problem. So one other setting that you might want to consider is setting up the notification parameters. You can configure SMTP server port, user password, and also configure a sender address and a list of receiver addresses. And this by default, notice email on success equals false. By default, Wax will only send emails if a renewal fails. But if you want to get a notification every time it runs to do a renewal, you can just simply change email on success to true. And anytime a certificate is renewed successfully, or if it fails, you'll get a notification about that. So that might make your life easier in sort of staying on top of the renewal process. So at this point, you should be issuing certificates and successfully renewing them with the win-acme client on Windows to protect your Windows Ldap servers. Remember, you'll need to rinse and repeat for every single domain controller in your environment for this to work, but you now should have Ldap over TLS using Let's Encrypt certificates in your environment. And this should make things a lot easier and smoother moving forward as Microsoft begins to rein in on these default configurations to make things safer for everybody.